When you haven't built a railway in 100 years, things change. For its new high-speed train, Britain needs a whole new line. 100+ kilometres of headaches.
It was like, what? They want us to do what? By when? For how much?
More than 150 bridges to be built.
It was like threading the needle through that space.
More than 20 kilometres of tunnels to be dug.
Tunnellers are extremely superstitious people.
And a Victorian jewel to be saved. The tracks will lead to a macabre discovery.
We were expecting a couple of bodies.
Some 7,000 bodies uncovered.
And to Olympic gold.
High Speed 1 is much more than a railway.
Wow!
That's what 300 kilometres an hour looks like.
(1996). In Britain, something strange happens when the new high-speed Eurostar emerges from the Channel Tunnel. It slows down. From Paris to the Channel, the train flies.
We'll be travelling at 300 kilometres per hour, which is our normal speed.
But when it hits Britain, it hits the brakes. 2/3 of its speed gone. On the British side, the Eurostar shares track with 20th century trains moving at 19th century speeds. Britain needs a whole new railway. 109 kilometres from the Channel to London. High Speed 1 will become one of the largest engineering projects in British history. It will take 12 years, employ 10,000 workers, and cost almost £7 billion, more than the entire budget of Kenya. The last time the British built a railway, Victoria was queen. And one of the route's biggest challenges is a Victorian relic. High Speed 1's London terminus. St Pancras Station is one of the most historic buildings in England. A palace of iron, brick and glass. When completed in 1868, this was the world's largest single-span roof. The acme of Victorian engineering.
This building's absolutely magic for me. That the Victorians could achieve this without all the computer power we've got, could achieve spans that they have. The efficiency, actually, when we analysed it, this structure achieved was quite fantastic.
But after the Victorians, it went to pot. Bombed in both world wars, poorly repaired, and facing the wrecking ball. In 1996, High Speed 1 acquires the building, and the team takes their first look inside.
I guess I was quite sceptical when suggestions were made about making this a destination station.
Behind its facade, St Pancras is darkness and dampness, diesel fumes and drug needles. Every hour, fewer than half a dozen trains arrive. Planners envision more than 30 trains. And something else. They dream of St Pancras as the next London attraction.
And I suppose the big question we had at the time was, can we possibly change this awful space from a liability into a fantastic asset?
At the other end of the line, groundbreaking begins, and engineers wrestle with their own problem: the risk of cave-ins. Mike Glover will work on High Speed 1 from beginning to end.
Every project has a key area of risk. And for the first stage of the railway, the North Downs Tunnel was the key area of risk.
The North Downs is a raft of hills in southeast England, the ripples from the creation of the Alps. Hills pose a challenge to rails.
Railways are different from highways in the sense that highways can hug the topography much more than railways can. And as a consequence, with high-speed railways, you have more tunnelling and more bridges to deal with than you would otherwise.
At Bluebell Hill, they have to tunnel through 3.5 kilometres of chalk.
The problem with the chalk, particularly in this area, is that it has vertical faults and weathering planes in it.
Outwardly, chalk looks uniform, but running through it are fault lines, where two masses of chalk have split. When water enters, it further weakens the fault zone. Chalk is also porous, so it can hold tons of water. Hit a fault, and the tunnel could cave in and flood. Double disaster. Chalk's not the only problem. Bluebell Hill is an ancient woodland, and some of its oldest trees lie in the path of the tracks.
When you've got a 100-year-old oak or beech tree, you don't just dig it up and move it. You can't. But what you can do is you can protect the most valuable part of ancient woodland, which is its soil.
They move acres of soil from Bluebell Hill. Into the soil, they'll transplant young trees using a special machine. Each blade exerts 25 tons of force. Typical load, 6 tons. More trees will be planted up and down the whole railway. In all, they plant a megaforest. $1.2 million trees. The young trees are growing faster than normal, thanks to old soil.
But it just shows the degree of planning that we put into the pre-construction phases to protect the ecology of the route.
At Bluebell Hill, they're ready to tunnel. But how strong is the chalk? To find out, crews drill boreholes into the chalk, probing for planes of failure. But the planes are so narrow, they could lie between the boreholes.
So unless our boreholes actually went through one of those, we would have missed it. So what we did during the construction of the tunnel, we actually do pilot drillings ahead of the hole to test what the materials are ahead of us.
If they hit a failure plane, they'll use giant screws called rock bolts to secure the chalk.
In the event, the quality of the chalk that we found, with 1 or 2 weak areas, proved to be of a higher quality than we could reasonably have expected. And that did contribute to us completing this tunnel 6 months ahead of programme and £5 million under budget.
Even despite North Downs' size, twice as wide as other tunnels on High Speed 1. The reason is speed and pressure. Trains enter the south end of the tunnel at 300 kilometers an hour, the maximum speed on the line. In a normal tunnel, such high speed would build up high pressure.
And this comes about really by the front of the train pushing air in front of it. And because the tunnel is smaller, it pressurizes, compresses the air, and you get the consequence of ear popping, for example, if the pressure is not relieved.
To relieve the pressure, engineers normally sink ventilation shafts.
In the North Downs Tunnel, that wasn't possible. As you can see in the rock mass behind me, we've got many hundreds of meters of material, and so a shaft was not practical. But what we do is we create a larger diameter to the tunnel, so that as the train comes into the tunnel, the pressure is dissipated.
Wow! That's what 300 kilometers an hour looks like.
Down the line, the railway of tomorrow yields a surprise from the past. Beneath the route of High Speed 1 lies more than rock. 2,000 years of history is buried here. The Victorians and Elizabethans, the Anglo-Saxons and Romans, and the tribes who lived here before history began. Someone has to safeguard England's heritage.
The archaeologists in many ways were the front line for construction, preparing the route so that construction wasn't delayed. And in fact, at one point when construction officially started, there were more archaeologists on site than construction workers.
Where Ebbsfleet Station now stands, they hit pay dirt.
A Roman settlement, a Roman villa, Anglo-Saxon watermill and an Anglo-Saxon cemetery.
And a big surprise.
We didn't plan for it. It was found when the construction workers were busy preparing for a small side road that brings you into the station here. And we had an archaeologist observing that activity, and he phoned me up to say that he thought he'd found part of an elephant. And as you can imagine, we were absolutely stunned, because this is an internationally important discovery.
A 400,000-year-old elephant is rare, anywhere.
That's during the Paleolithic period in the UK, and it's an elephant, not a mammoth. It would have been much warmer in the landscape at the time, so it didn't need fur of a mammoth. And this whole area would have been a completely different landscape than the one we see today. We think it got stuck in the mud or the edge of a small lake. And what's particularly interesting is that we found pieces of worked flint, that's flint that has been made by humans, in and around the skeleton and also on the bank of the bog or the lake. And therefore we know that our ancestors were in and around the elephant. Whether or not the elephant had died and they were butchering it, we're really not very sure. But to have human interaction with this beast is just amazing.
13 kilometers away, crews inching towards Ebbsfleet hit a worst-case scenario. A mega disaster. To build a bridge for the Eurostar across the River Medway will take the world's longest high-speed rail span, 1.3 kilometers long. So long, the builders have to weigh the worst that could happen.